Okay, in this video, I'm going to go over some of the stuff from chapter 2 in the book. Again, the textbook has been delayed for whatever reason. Hopefully you'll get it soon. But until then, to be able to go ahead and do the homework and go ahead and get the class started, I think we only have 8 weeks, so I don't want to waste one. I'm going to go through the basics of what the chapter covers, okay? And then for the homework, I'll post it to Moodle. I'll actually write out the problems rather than point to problem numbers because you don't have that yet, okay? So chapter 2 is where we first start making Java programs. So before you can do this, you have to have your editor downloaded. I'm going to use Eclipse in these examples. You can use whatever you want. Okay, again, and I'll say at other places, make sure that you upload both the Java file that you create and the class file, okay, or the executable file, okay, which doesn't have any extension at all. And we'll see that as we go along, okay? So in this chapter, we'll do the hello world again. I already have that one up. We'll take a look at that. And then we'll use input and output statements. We'll talk about the Java's primitive data types. Okay. We'll look at some basic memory concepts. We'll look at the arithmetic operators, and then we'll write some decision-making statements, and we'll use relational and equality statements. Okay. So again, all of this assumes that you've done some other programming somewhere in your life. Okay. So let me go ahead and do the full screen share here, I think, because it may open up in multiple windows. So I've clicked on the Eclipse IDE. So we're going to go ahead and pop that up to get started. Sometimes takes it a little bit. Okay. And we still have up here our Hello World program. So just to be clear, if you look at the top here, it tells us that this is a hello world.java. So the files that we create are .java files before we compile them, okay? And again, as I mentioned in the other video, unlike other languages, where for something like Python, which most of you, I think is the other class that you had, that with Python, that you would create your program as a .py file, and then you run it live, basically. You don't ever create an executable, okay? Whereas in C++, you create a file, typically a .cpp file or maybe a .c file. You would then compile it into an executable for the computer that you're on, which means if I compile it on my Mac, it's not going to run on your Windows, okay? What Java does, Java created this virtualization layer. So if you're running a Java program on a Mac, you're running the Java virtual computer. If you're running on Windows, you're running the Java virtual computer, okay? There's a little bit of a hit in performance because of that, and you don't have the full abilities that you would get in a native program. So you don't tend to see a lot of games written in Java. But what you gain is I can write a program for the Java virtual machine on my Mac and send it to you on your Windows, and it's going to run just fine. Okay, so that's where we're at. So the .java file is the basic file. We're going to compile that into a class file, okay, that has no extension, okay? And that's what's going to be our executable. And when you turn stuff in, I want you to turn both in, okay? So just to go through, again, when we're in Eclipse, we have to identify a package, okay, which is just a collection of programs. Then we're going to create our public class, hello world. Whatever this is called has to be what the file is called. Okay, so if I call my program program1, or the way I like to do homework is like C2P5 for chapter 2 problem 5, then my class name would have to be C2P5. Okay, by practice, and the editor may complain if you don't, you want to capitalize that first letter of a class name. Okay, so that defines the whole structure. Okay, every class, if it's going to be one that you can run and not some kind of a helper one, has to have the public static void main string args. Okay, when this class is referenced or executed, or you try to do something with this class, this main function is what is going to be what runs. Okay, and in this case, we just have the system.out.println, which is going to do nothing but print to the screen. This is the same as the Python print command. Okay, and that's all we've got there. Okay, so that's what the book goes through first. It's a slightly different program, but that's the idea. Okay, And then it shows us that we can do multiple print statements if we want. And in fact, we can, if we want, put in the \n, okay, which is going to be a new line character, okay. So now when I go to run this, again, I can do a run, you'll see that I have hello on one line, world on the other, okay. Other things you can do up here, you can do a T for tab. Okay, so if I wanted to not do that, do a run again, and see there's a tab there. Do multiple tabs, all that, okay. Note also that these have to be inside of a string. I'm between the two quotes here and here. I couldn't, for example, do something like that. That would give me an error, okay. And note that the editor says, yeah, that's a problem. Can't do that, okay. So delete these tokens. Okay, I'm gonna delete them. Okay. So that's the first couple of parts talk about this. Okay. And then the other thing we can do with print. So there's a new or a different print thing. And if you're a C++ programmer, this will make a little more sense to you. And that's a formatted print. Okay. So it's still a system.out.print, but it's printf. Okay. And the printf takes two things. The first thing it takes is a format string. Okay. So we're going to have, again, in our double quotes here, in this case, we want a string. So it's a %s for a string, followed by a %n for a number. Is that a number? No, that's a new line, sorry. %s for a string, %n for another new line. So that's going to be a string, a new line, a string, and a new line. Okay. After that, we have to fill in what we want to go there. Okay. So the first string it's going to look for, we're going to say welcome to, and then the second string we're going to look for is Java programming. Okay, it's a little bit bigger. Give us plenty of space. Okay, so what this is going to do when it goes to print, this %s, it's going to take the first thing that comes as a parameter after that. It's going to place that. It's going to do a new line character. The second %s is going to go to this one. Okay. If we run this now, we see we get the welcome to and Java programming. Okay. If for some reason you don't do that, you just put one thing and run it. It's going to give you an error. Okay. It's going to say, you said a string was coming, a string didn't come. Okay. You also have to make sure you have the correct kind of data. There's a way to print numbers, but this is not it. Oh, actually it took it. Okay. See, it's really funny that I say things are it's gonna be strict and it's not. But yeah, so it's treating it like a string, not like a number. Okay. So the next thing we're gonna do, the next program we're looking at here, we're going to do some input and some output. Okay, so I'm going to go ahead and create a new program here. So let me go ahead and close all editors. Let me go ahead and do a file, new. We start with a new package here. Okay, and if I browse this, it's odd that I said hello to begin with, and I may be stuck with that. Yeah, we're just not worried about that. Don't name yours hello. That was dumb. I don't want to take the time to figure that out. So let's instead back into a file new. We'll do a class this time. Okay. And we're in the hello. That's fine. That package we're not going to worry about. Okay. I would name yours something like the class name or something more reasonable than I did. We want this one public. Okay. And we're going to call this one addition. Okay. And again, we want it to be public. We want it. We're gonna the superclass here is the Java language object. If we were making a hierarchy and there was an existing class, we would change that. We don't. We talked about the interfaces. We don't care about that yet. Okay. We don't have any abstract methods, but we can go ahead and put that anyway. It's not gonna hurt anything. We can also do, if we have a superclass, constructors. We don't want that, but we're gonna need this public static void main. Okay, so we're gonna go ahead and click that. You can always add that yourself, but we might as well let it do it for us. Okay. So then when I say this is what it gives us: the package hello, the public class addition. Okay, the public static void main string args. Okay, and that's what comments look like, but we're not going to put that. So what it puts in the book here, okay, we've got the main method. Begins the execution of Java application. So this is where things start. Okay. So we're inside of the main function. We're inside of the addition class. Okay. So what we're going to do in order to add these two numbers. Okay. So what we're trying to do here. So the whole point of all of this, in fact, we can put a comment up here. We want to add two numbers. Okay. So we want to accept two numbers from the user and display the sum. That's all we're doing. Okay. So in order to do that, so right off the bat, we're getting into one of the joys and the frustrations of Java in that we don't really roll our own. We're going to take advantage of the tools that are there. Okay. And the first thing we're going to do is create a scanner object. Okay. So a scanner is something that allows us to input things. It's pretty specific, or pretty, not specific, it's the opposite. It's pretty general. We can input a lot of things. Okay. But in order to do that, we have to go up before our class. We have to import it. Okay, so we're going to do an import java.util.scanner. Okay, and then do a semicolon. Okay, this is going to tell us that we've imported it, but we haven't used it yet. Well, of course, because we just did. Okay, so I'm importing from the Java main library, from the util subcategory, the scanner object. Okay. If you try to run this without importing it, it's going to give you an error. Okay. So I'm now going to go down here. And the first thing I'm going to have to do is going to be to create a scanner object. Okay. So I've got the scanner, the class there. That's what I'm importing as a scanner class. So I'm going to create a scanner object or a scanner instance, either one, to obtain input from the command window. Okay. And to do this, I'm going to start with the name of the class. So it's a scanner. I'm going to call it input. Okay. So I'm creating an instance of scanner called input. It's going to be equal. I'm going to use the new keyword, which is going to call the constructor for this class is the same name as the class, which is generally true. Okay, so it's going to create a new object, a new instance of the scanner. It's going to run that scanner constructor, which is going to create an instance for us on system.in. Okay, so the system.in means to take something from the standard input, which is a keyboard. Okay, that's all we've done. And again, it's going to tell us, hey, again, that's not a warning. That's just saying that, or it is a warning. It's not an error. Okay. Again, input isn't used. Okay, well, we know because we just did it. Okay. So now we're ready to go ahead and input something. Okay. So we're going to start. We have to let the user know that they want to do something. We have to do the prompt. Okay. So to do that, I'm going to do a system.out.println. I don't have to worry about formatting. Okay. In fact, I'm just going to do a print. I don't think all versions support that. Okay. System.out.print. Enter first integer. Colon, there's a space there, and then a semicolon. Okay. So this one I'm just going to say, and again, the difference of println puts a new line character at the end. This doesn't. Okay, so that's the difference we're saying. So when I print this out, it's going to leave the cursor where I can enter the number. Okay, in fact, I can go ahead and run this, and I encourage you to run things often. And you see that when I go down here in this window, see, I'm right there. Okay, and I just need to do anything and it's going to stop. Okay, if I would have made this a print line, just so you see the difference, and now run it, and I go here, you see I'm down here on this next line. Okay, so by making it just a print, that's going to make it easier to see what's going on. Okay, so now I want to create a variable to be able to store this value. Okay, again, this is going to look very much like C++ if you've done that. Python is an untyped language in that you can just, variables can be whatever they are. Okay, Java is a strongly typed language, which means I have to say what it is. So this is going to be an integer. I'm going to call it number1. Okay, and it's going to equal. Okay, so I'm going to create a new variable called number1. It's going to be of type integer. It can't be a string, can't be a double, can't be a float. Okay, I'm then going to use my scanner object I just created. Okay, I can do an input dot. Okay, and what I want to get from that, if you look in the pop-up menu that pops up, I have to go back to there. Okay, I want to go to this one. This is going to take whatever comes off the keyboard. Whenever they hit enter, it's going to get the integer and pull it out. Okay, so my int number1 is equal to input dot next int. Okay, I have to put a semicolon or it's going to complain. Okay, it's again going to say, well, hey, wait a second, you didn't use that. Okay, oh, that's odd. It's saying input's never closed. So let me see, that's a different error. Okay, what did I do that I shouldn't have? Scanner input, and it worked, which is weird. It's equal to new scanner system in. Yeah, it looks okay. I don't know what it's complaining about. Sometimes it complains for really odd reasons. Okay, so that looks like that's okay. Let's go ahead and test this out and print it out, just make sure we're getting the right number. I'm gonna do a system.out. In this case, I can do a print line, because I wanted to go ahead and do that next line, number1. Okay, and put that there. Okay, so now let's run this. Enter an integer, let me do 56. Prints out 56. We're good. Okay, let's check just to see if we enter something crazy, is it going to protect us or not? So let's enter hello. Okay, it's going to throw an error. Okay, which we're going to have to deal with, but at least it's not going to just let us keep going on with bad data. Okay, it's part of the reason we use the scan. Okay. Okay, so now that we've got all that working, we can go ahead and actually change this then. We're going to go ahead and do, well, I'll keep that there for the other one. Okay, so I've got the first one. Let's do the same thing again. I'm going to be lazy and come down and copy and paste. This time I'm going to say enter second integer. Okay, and then my number2 is going to be equal to input dot next int as well. We'll go ahead and print number2. Make sure that part's working. Okay. So again, what doesn't like there? Number, oh, it's not used yet. Okay. We know that. Okay. So we're going to enter a 6. We're going to enter an 88, and it's going to print 88. Okay. So far, so good. So now what we really want to do here is we want to do some math. Okay. So I want to create a new integer called sum. Okay. And I can just do it like this, and it's fine. And it's again warning me I haven't used it yet. Okay. Then I could say sum is equal to number1 plus number2. Okay. And then I can print out sum. That's all okay. Okay, so we'll start with it that way. So we enter in a 5, we enter in a 7, and it gives us a 12. Okay, life's good. We don't have to do it that way. We could also do it just on one line. So I can come back, and this is the preferred way. The sum is equal to number 1 plus number 2. Okay. They both work. Going to be just fine. Okay. Now we're going to use our printf function again because we have a mix of both string and data. Okay. So for this, I'm going to say, I'm going to have in my print, let's say the sum is. So that's just going to print as a literal. And then I'm going to put in a number. So put a D for number, it's a digit. Okay. And then a new line character. Okay. Which means over here, the only thing it wants me to fill in, not like that, should be a comma. The only thing it wants me to fill in here then is going to be a digit or an integer, okay? Which I'm going to say sum for that, okay? So again, it's going to print out on the screen, sum is, the sum number I just calculated is going to put right into there. It's going to put a new line character, okay? Note also that if I were going to say sum equals, I could do this, but if I say int sum is equal to sum plus 1, okay? This is going to give me an error because I'm trying to reuse a variable, okay? The duplicate local variable sum, can't do that. I could, if I wanted, refer to it just like that. So we can only declare it once. We have to declare it as a type, okay? And I'm sure in a minute we're going to see all the types that we can have, okay? I don't really want to do that, so we'll get rid of that. Okay, so let's run this now and see what we get. Enter our first integer, we want a 9, and we want a 67, gets us the sum is 76, okay, which is correct. Okay, so the book's going to give you some more detail on how to do all that, but that's all through section 2.5. Yeah, all through 2.5. Okay. So 2.6 talks about memory concepts, which we're going to hit more as we go along. In this program, we have number one, number 2, and sum. So those all refer to some place in memory. So when you start up the application, the operating system is going to give you a spot of memory. I like to think of it as like a spreadsheet with rows and columns. Okay. Because we said integer here and here and here, then depending on the operating system that we're on, it's going to give us however big an integer is. It's going to give us so many boxes to put things in, okay, that are reserved to that. So number 1 points to that memory location. We say variables in programming. They're not really variables. A variable in math is something we don't know the value of. Our variables in programs always have a value. It's whatever's in that memory location. Okay. So if you put something in memory, just so you know, if you turn the computer off, memory's gone. It's what we call volatile. Okay, so you're not writing it to a hard drive. You need to write it somewhere if you want to save it. Okay, so we're just doing temporary stuff. Okay. The arithmetic stuff is in section 2.7. We've done a plus here. We could have also done, just so you have the full list here, minus for minus. We do an asterisk for multiplication. We do a slash for division. Okay. And then we can do a % sign for modulo. Okay. Or remainder. Okay. So the remainder turns out to be pretty important. You probably saw that in Python. If not, we'll get to that. Okay. So when you're going from an equation in math to an equation in programming, it's more or less the same as it was for Python. No difference there. Use parentheses if you're unclear on how the order of precedence is going to work. Parentheses are never wrong, even if they're not needed. The order of precedence is going to go like math does. Okay. And then it's going to start with multiplication, division, and remainder first. And if they're all the same, it's going to go left to right. It's actually going to do parentheses first and then exponentiation next, but then it's going to do multiplication. Then it's going to do addition and subtraction. Okay. So when the question is, what you'll see on Facebook, like what does this equal? The orders of precedence are still going to happen. Okay. So as an example of this, we're going to create something. They've got the algebra statement. M is equal to the numerator is A plus B plus C plus D plus E, and the denominator is 5. Okay. To do that, I would have to say an M, which I would have to give it int or float or something. M is equal to, I would have to put in parentheses, the numerator, the A plus B plus C plus D plus E, all of that divided by 5. Okay. So that makes it clear, and it's giving me errors here because I didn't define A or B or C or D or E. Okay, but this is what the format would look like. Okay, so all of this is on the top, all of that's on the bottom. In fact, if you're ever concerned, you can do parentheses for numerator denominator just to keep you straight. Okay. Something like our old friend, y is equal to mx plus b. So if I wanted to do y is equal to mx plus b, I would do that as y is equal to m times x, usually put a space, times x plus b. Okay. And just like in algebra, this is going to happen first. But if you're paranoid, this is not wrong. Unnecessary, but not wrong. Not going to take any points off for that. And then, of course, that would need the semicolon at the end. Okay. So I think there are lots of examples in the book there on how you could work that out. But that's the basic idea of how those things work. Okay. So let's see what else we have here. Okay, decision making. Okay, so we get to, in addition to this, we can leave all this stuff. This is all okay. We're going to get to a decision making statement. Okay, so all of programming really comes down to, you've got variables, you've got statements which do things, you've got control structures that are, or conditional structures, okay, that if this happens, do this, if not, do something else. And then we have sequential, which is a normal way, or we have repetitive. That's all we have in any language, okay? So when we're looking here to do the if statements, okay, if statements work kind of like they work in Python, which is good. So I can say here, if, and then in parentheses, I have to have some condition that's going to evaluate to true or false, okay? So with that, my options are, and like Python, 2 equal signs is going to be equality, okay? I can do a not equal, which is the exclamation point equal, okay? I can do a greater than, I can do a less than, I can do a greater than or equal to, I can do a less than or equal to, okay? All of those are available, okay? So remember, if I say y is equal to 5, that's a statement. I'm assigning to the memory location referred to by y the value 5. If I say y equals 5, I'm asking a question. Is y equal to 5? Okay. That is sure to hang you up. In fact, we'll do it wrong and see what this editor does. Hopefully it'll correct for us. So if I'm going to say if sum is equal to 100, okay, that's the general idea, okay, and I like to put parentheses. Not everybody does. In fact, I like to do this if it were me, but you do you, okay? That's how I like to do things, just because I think it's more clear, but you don't have to. If you only have one line for your statement, then you don't have to have the first parentheses at all. Oh yeah, it may still. The book has it, but see, the book puts it on the same line. What the book does is this, and I just don't like that, but you do you, don't care, okay? So let's see what it's going to tell us here. It's going to say, can't convert from int to Boolean, okay? Which is good, okay? This is going to have an integer result, and it has to have a Boolean. Remember, Boolean is true or false. This needs to evaluate to true or false. So this won't let us get past that, which is good, okay? And I think C++ just, it's always true if you say that. So I put if sum equals. Now it's saying, does sum equal be 100, okay? So then we can just print something stupid here. system.out.print line. It is 100. It's all dumb. We're just doing dumb stuff here. Okay. Semicolon. Okay. So now if I go through and run this and enter, let's say 40 and 60, then yeah, it is 100. Yay. Okay. So again, the way the if statements work here on any of these, if this condition is true, this executes. If not, it skips it all and goes down to the next line. Okay. So they're doing a comparison program there. Okay, is that the last thing they're doing? Yeah, let's go ahead and we'll do this one as well. Okay, so this is a different one, and I'm just doing all kinds of random things all at once. Well, let's just do a new one. Let's just start over again. Okay, we're gonna do a file, new class. Just get us used to this. The name of this class is going to be comparison. It's going to be stored in the comparison.java. Okay, we want to go ahead and put our public static void main in. Everything else should be the same. Okay, so now we have a new program. Now we can go ahead and close this one. It's fine. Okay, so now we've got this comparison class. Okay, we're also going to need to import the java.util.scanner. Okay, I'm importing the Java util scanner. I'm guessing I probably could have copied a lot of this program from before, but it doesn't hurt to get another example. The day's young, we can type. Okay. So then in here, we're in our public static void main. We're going to again do our scanner. Input is equal to new scanner from our system.in. Okay, so we did before. Note that it makes some of those things, different looking to show that they're part of the system. Okay. Then again, we're going to have our system.out.print to enter our first integer. Again, I could have just copied this all, but I didn't. Okay. And then we can do our int number 1 is equal to input.nextInt. To read in our first number. Okay, I'm going to copy this stuff to our second integer. Number 2. Okay, we now have our two numbers. So I can now do the following. I can say if number 1 is equal to number 2. And I'm going to do it that way, but you can do it whichever way you want to do it. Then I'm going to do a system.out.printf. And in this case, my printf, I'm going to start by doing my integer, which I do with a digit. I don't know why all that's there. Okay, I'm going to printf this, whatever's in the %d is equal to the second %d. Okay, and then do my new line character. Okay, so that's the format string. What am I going to put there? The first digit I want is going to be number 1, and then number 2. In this case, it doesn't matter which way we do it. Okay, then I have to put. Okay, then ideally be that there. It thinks I'm missing. Oh, I am missing one. Yeah. Because I open up the class here, int main here, I have to close. In fact, I can put a note, close main, close. just so I'm clear. Okay. So let's try this, see if this works. Run this. And if I enter a 5 and a 5, it says 5 equals 5. Okay. And to make sure it doesn't always do that, if I enter something else, if I enter a 5 and a 2, it doesn't say anything. Okay. So now we're going to go through and check for other conditions here. Okay. The next is going to be a not equal. So I can copy all of this and paste it. But this one, I'm going to say if number 1 does not equal number 2, okay, then I'm going to do the not equal over there. Okay. So now one of these is always going to happen, right? It's either equal or it's not equal. Okay. So if I run this now, if I have a 5 and a 5, they're equal. I run it again. If I have a 5 and a 6, they're not equal. Okay. And there are more to check here, but we'll do one more just to get the basic idea. Let's say we want to see, I didn't mean to do that, but it's okay. I wanted to copy instead of cut. So let's say I want to see if number 1 is greater than or equal to number 2. Well, let's just do greater than. Is number 1 bigger than number 2? Okay. If so, I can just print this out. You can see I can copy and go this way. Okay. And we can check all of these things. Okay. Note that if I would also, and while we're here, let's go ahead and do one more. If I do a greater than or equal to, because of the way it's designed, these aren't connected through ifs. I mean, these are all separate things, right? So if the numbers are equal, then this will be true. So this will print out, but this will be true as well. Okay. What happened to my not equal? That's weird. I had it as a not equal. So these are not exclusive. It's going to look at each one separately. Okay. Also, if I put, and we'll do this as a test, if I put number 1 being bigger, then it's going to print out both of the last 2. Okay, so let's run this and see. Okay, so if I enter, that's all I wanted, down here, if I enter a 10 and a 5, okay, oh, multiple things here, right? The 10 not equal to 5 is true, 10 is greater than 5 is true, and 10 is greater than or equal to 5 is true, okay? So this is going to tell us lots of things about these numbers. If we wanted to make it unique, we'd have to put an else. We didn't talk about else in this chapter, okay? So let's wrap up what we talked about. Okay, we've been through the Eclipse IDE. We have an idea what it looks like. We have done the system. We started with the print. We don't have it here anymore. We start with the print line, print ln, which prints whatever string you give it, then a new line character at the end automatically. We have the print, which doesn't do the new line automatically. We have the printf, which allows us to do this format string and then use these special words or special symbols to pull from some variables to put in our print. Okay. We've also gone through the scanner class, which we're going to use to allow it to input from the keyboard system in. That could be modular, it could be something else, but that's all we're going to worry about for now. Okay, so we have input through scanner, we have output through the printf and print ln. Okay, then we're going to do some variables here with the int keyword. We're just doing integers now. We can do other things later. Give it a name, and we're going to use our scanner to get the integers here. Okay, we also did, and the other one did the arithmetic, sum is equal to sum plus 1, or sorry, sum is equal to number 1 plus number 2, which we can do. We can do division, multiplication, all those things. You can use parentheses. The order of precedence doesn't change. Then now we're getting our first control structure here where we have a choice. So it's a selective control, okay? If some condition is true, whatever's inside of the brackets is going to be what executes, and if not, it won't, okay? So if this is true and they're the same, this will print out. Any line here, there could be 100 lines here, but whatever's between this bracket and this bracket will happen only if and only if this is a true condition, okay? And that's how those are going to work. Okay, so look through these examples. The next thing I'm going to do is going to be to type out the homework problems instead of by number, by actual name, okay? So that'll be the next thing that we do, and we'll go from there, okay? So it may be useful actually just to talk about the homework problems. So the first one I'm going to give you is 2.24, and I'll put this one out there. That's write an application that reads 5 integers and determines and prints the largest and smallest integers in the group. And for all these, only do things that we've talked about, okay? So don't use if else. If you know how to do that, good for you. That's all we're doing, okay? Okay, sorry for the glitch. My dog was having an issue. Okay, so this problem, you have to use things that we've covered in this chapter, so don't use things you don't understand, okay? So for that one, you're going to, first you have to when it says read 5 integers, you're going to have 5 inputs using a scanner, okay, with 5 different numbers, number 1 through number 5, okay? You're then going to go through and use ifs to determine which one's the biggest, okay? You think about the algorithm of the simplest way to do that, okay? Then we've got another one, 2.25 is write an application that reads an integer and determines and prints whether it's odd or even, okay? And let's go ahead and do this one. This is a preview of coming attractions, okay? Just because this one is so useful, but tends to confuse people, okay? So at this point in the program, we have a number called num1, integer called number 1, okay? So the if I want to do here, if I want to see if it's even or odd, let's think about that. How do I know if something's even? It's divisible by 2. What does that mean? It means that if I divide it by 2, I'll have a remainder of 0. Okay, so I can just say if number 1 mod 2 is equal to 0. Okay. Then I can do that and do that. Yeah, that's what I wanted. So if number 1 mod 2 equals 0, which means I take my number 1, I divide it by 2. Is there a remainder? If there's not, I can do a system.print, system.out, sorry, it's been a while since I've taught Java, print line even. Okay. We don't know how to do an else yet. So I would have to instead say something like if number 1 mod 2 does not equal 0. Wrong way, that way, do another one that way. Yeah, then I can do the system.out.print line odd. And both of these need semicolons. Okay. So let's see if this one works. So again, this mod 2. So when I run this, and it shouldn't say first integer because there's only one. If I say 5, okay, if I do 5 divided by 2, what do I get? 2 with a remainder of 1. So that's an odd number, okay? So let's run it again. This time I enter 1,000, okay? If I take 1,000 divided by 2, I get 500, no remainder. That should be even, okay? So that's how that works. That's pretty much, I've done for you. Problem 2.25 is now done, so you don't have to worry about it. Problem 2.28, diameter, circumference, and area of a circle. Okay, so on this one, we're going to use 3.1415, which is going to be a floating point number. Okay, we can also, it tells us here we can use a class math, which we don't need to import, but we're going to basically use the formula for the circumference, the diameter, and the area of a circle. Okay, using that pi. And we'll just have those to print out. And for those, for a floating point number, we're going to do a %f for that number. Okay. Okay, let's see. It doesn't tell you. I think it's float. Let me make sure that's correct. Because it's float in some languages, it's doubles in others. So I can say float x. Yeah, float. Okay. So in that case, we're just going to have like a float for, I could say float pi is equal to 3.14159, for example, would work. Okay. Or again, I could just say something like float circumference or area is equal to 2. No, it's not 2. It's pi. I could do math.pi times, let's say the radius is 4 times 4. Okay, that would work as well. Or if we had the variables defined, I could say r. Okay, there's a way to do squares, but we haven't got it yet, so we would do it this way for now. Okay, so that's 228. It's going to look like that. Okay, 230, separating the digits in an integer. So that one I want you to think about. Okay, so for that one, what they're saying is, if I give you the number 4, 2, 3, 3, 9, for example, okay, you're going to put a 4, 2, 3, 3, 9. So you're going to pull those apart, those individual digits apart. Okay, that's going to require a little bit of thinking. Okay, and then the last one there is one of their making a different section programs that requires a little bit more thought. Okay, it's on World Population Growth Calculator. So search the internet to determine the current world population and the annual world population growth rate. Write an application that inputs these values and then displays the estimated world population after 1, 2, 3, 4, and 5 years. Okay, so you have to look up somewhere the current world population and the current world population growth. Okay, then you'll start with that, and if it's 1 million people, which, or it's not, let's say it's 1 billion, which again is not correct. I think last time it was 6 billion, 10 billion, I don't know. Let's say it's 1 million. So it's if you're growing at 10% a year, then year one, at the end of year one would be 1 million times 1.1. And then you would take that next number times 1.1 for year 2, all the way up through year 5. Okay, that's how that one will work. Okay, and again, I think the easiest way to do these is to name our programs as C2P whatever. So that one will be called C2P34, which means that's what your class name has to be. Okay, so again, the one we've got here, the even or odd. So let's do that as an example. Of course, we got lots of crap there. This would be a public, and this is going to complain. I would have had to have named the file this, but that would be capital C2. Which one was that one? 25. So it'd be C2P25. Okay. And the P doesn't have to be capitalized, but that way when you turn it in, I'll be able to see it. Okay. So again, you'll have to know where these files are located, and it asks you that somewhere along the way. Okay. So when you go to turn them in, so on mine, I can just always do a search. So I could do that. Hello world.java. Okay, I can go to that. That's not where it's at. That's when you're installing Eclipse, see where it asks you to save your files. I don't remember because I didn't pay attention because I didn't, which is unfortunate. Let me see if I can find it. If I go to the Finder, oh, here we go. It's in Recents, but it should also be in somewhere. It's probably in my home folder. So let's see if I can get one of these in show in folder. So let me go back one. Yeah, that's where it's at. Oh yeah. So for me, it's under my hard drive, under users, my name, Eclipse workspace, hello, source, hello. And that's where these files are. Okay. So this would be one of the files that you turn in. I assume it's odd that when you run it, it doesn't create a class file. Oh, because that's in the source directory. If you go back up 1 to hello. The bin hello is where those are. Okay, so I'm glad I did that. So there are two things that you turn in, and the .class file is what you'll need as well. It doesn't always have, when you're running it, you don't have to say .class, but it does have a .class. Okay, so wherever you put your files. Okay, so for me by default, it was in my home directory, the Eclipse workspaces, and then the hello package. Okay, it'll have two directories there. The src hello will have the actual Java files. The bin hello will have the class files. Okay, and these I should be able to run. Yeah, who knows why I didn't do that from there, but you can run them within the other. Okay, but that's what you need to turn in, those two things. Okay. Okay, it's been a long video. Hopefully it all made sense. I'm going to go ahead and post the homework now. So take a look at that and let me know if you have any questions. Again, there's a separate forum for chapter 2 questions that you can put in there as well. Okay. Okay, so also make sure that you weigh in on when you want to have our weekly Zoom meetings and all that stuff. Okay, talk to you guys later.